Hello and welcome to my channel. First, I want to wish you a happy new year, and it seems that we have survived the year 2020, and I want to wish you an easier year 2021, and I hope everything will be far better than it was in the previous year. Today we are going to talk about the builder design pattern in TypeScript. And I've been looking at some articles describing the design pattern, and I couldn't get away with a concise theoretical corollary of the design pattern. So I wanted to do my own explanation of the pattern and to make it easier to remember and easier to understand. Basically, the design pattern, the builder design pattern, is about complex objects. You don't need to remember anything. I'm going to make you remember only two simple things about the design pattern. You have a complex class, and that complex class is really huge, and that class contains many other classes, and those other classes can have their own class hierarchy, and they might have many subclasses, and the tree can be independent of its own, and you need to create the instances of that complex class in steps, which means in something like a pipeline, something like this. So this is the only thing that you need to remember: a complex class, a pipeline, and what a so-called director or manager that directs the builder in the steps needed to create an instance of that complex class. So, for example, let's talk about a spaceship. Okay, well, for example, if you want to create a spaceship, which is obviously a very complex object, well, first you need to research the spaceship. You need to decide the weight that it's going to be, and you need to decide the payload that it's going to carry, and it's going to be constructed of a certain material, composites, and how many engines it will take, and etc, etc. So first you create the spaceship hull, and then you create the engines, and the engines themselves are very complex objects, so they need a builder of their own. And the spaceship consists of let's say rooms or cabins inside, so you want to create those independently, and then you are going to assemble all these objects into a one complex object, which is the spaceship. The same goes, for example, when you want to buy a vacation. When you want to go on holidays, you first talk to your travel agent. You tell them what are your preferences, the destiny where you want to go, the type of accommodation you want to buy, the type of food you want to eat, and the travel agent is actually your director. It's this. He's receiving your preferences, and he directs the creation of the vacation package for you. Okay. So I'm going to try an example which could be probably practical for those software developers of you interested in, let's say, computer games. So I'm having a game object, which is obviously also a very complex object, and that game object will be having many subsystems: the graphics subsystem, the sound subsystem, the logic subsystem, the network subsystem, and it will be having also the game world, which is a set of 3D objects in a certain 3D environment, and it will be having also a container that will be containing the all the subsystems, for example. And as you can see, this is a composition of many subsystems, and also a composition of other objects that the game object consists of. So, and as you can see, the subsystem is a interface. It represents a object or class hierarchy by itself, and you derive the other subsystems from that. So you have the game logic subsystem, the game graphics subsystem, etc., etc., etc. So I didn't draw everything. Okay, and you have the game builder. The game builder will first create the various subsystems and the various instances, object instances, for example, the game world. Okay, if you can see. Oops. Okay, and it will set the game object step by step. And the main application, which is the director, will be dealing with the game builder. It will just tell the game builder, okay, create me a game instance and return that to me. And that's it. We are going to start implementing this example. And of course, this is very oversimplified, because if I'm going to implement all the details, then it will be taking me hours and hours and maybe weeks, because in that case we are going to implement a complete game, right? And we don't want that. We are just discussing the design pattern itself. Of course, there is one thing. The game builder itself can be representing also other design patterns. For example, it might be a singleton, because you don't want to create more than one game builder, for example, in your application. You might want to create let's say you might want to create a game that is a Pac-Man game inside your 3D first-person shooter game. Okay, so your player comes to a display inside the game world, and on that display, for example, a Pac-Man game is running. Okay, so you can do this. Okay, the point is the builder itself might be also another representing another design pattern as well. But the point of the builder is to direct the creation of complex objects in a step-by-step manner. So let's dive into that. So I have created a folder called the builder design pattern in TypeScript, and there is nothing. I've only cloned the GitHub repository. So the code of this example will be found if you follow the link in the explanation, the description. And the first thing that I'm going to do is creating, as always, I'm using Dino. I'm using Dino for programming this example, as always, because it has a built-in support for TypeScript. So I'm creating a folder for VS Code settings. And inside that, I'm going to create a settings JSON file, and I'm going to copy that from previous projects. Copy the settings. So I'm enabling Dino. I'm enabling the unstable interface, because I want to use lint in case I want to use lint. I'm also defining the TypeScript formatter to use the Dino formatter for VS Code, and the IntelliSense to be from Dino. And that's it. I'm going to save this. Yeah, I need to reload this thing. So, okay. Okay, so let's create first a main TS file, and here we are going to do what? We are going to call the game instance, and we are going to call the game builder instance. So which I'm going to create in a bit. So I'm going to import the game builder from, let's say, game builder TS, and it's shouting out because I don't have the files created yet. I'm going to import also the game class from game TS. Okay, I'm showing you actually the top-down approach to create such an example. So I'm showing you that I'm starting from the top first component, which is the main application, and I'm going to go down step by step. So we will be having a main function, which is an async function. You might use async operations here because some steps might be asynchronous and you want to wait for them to finish. It depends on the operations that you are going to provide. For example, if you want to read data from files, then definitely you need to use promises and async operations. So const, let's say, game builder, which is new game builder. Okay, const game, which is of type game, and I'm going to say await game builder. Oops, build game. Okay, so this is the manifestation of the builder pattern. Okay, you are the director, which is the main TS file, and you are telling the builder to create a game for you and to return that instance. So it is doing exactly just that. And just to show you, I mean, how the application is going to work in a game development context. So I'm going to say set interval, oops, let's say I'm going to render the game and to update the game. And of course, if you are doing a real game, then you will be having many other operations. And I'm going to do this, execute this every 2 seconds. Of course, if you are having a real game like 3D first-person shooter, then you are going to do the updates many times frequently. So after that, I'm going to call my main function. All right. So now we are going to do the builder file. So let's create game builder TS. And in that builder, we are going to define the subsystems. So, okay, so import, I'm going to import the game graphics subsystem from game graphics subsystem TS. Okay, and I'm going to do what else? So we are going to do the game graphics subsystem, sound subsystem, logic subsystem, and network subsystem, and in a different class we are going to do the game world. Okay, so import game network subsystem. Oops. Game network subsystem, and I'm going to just copy that game So also we are going to use the game world class, which will be created in a bit. From of course, I'm not creating any folder structures for you. You can create a source that folder for those, and you can divide that source folder into other subfolders like subsystems, for example, and game logic folder and game data folder, etc., etc. But for this example, I'm just going to make everything residing in just one folder for the simplicity's sake. Import game. We are going to use the game instance as well. From game ts, and we are going to export class game builder, which is going to be implemented in a bit. I think I'm going to implement the first method here, which is async build game, and that should return a promise of game. And I'm just going to say return await game. Oops, not that. Const game equals new game, like that. Of course, I'm going to modify this, but first I'm going to create the subsystems and the game world. So let's go and do that. So game graphics subsystem ts. Okay. This is going to import an interface which is called Subsystem, and we are going to create it in a bit. From Subsystem ts, and let's go and do it right away. Subsystem.ts. Okay. So the subsystem is just a very simple structure that defines an interface that you can implement in your subsystems. I mean, it's a sort of inheritance way to well, you know, you get the idea. So interface subsystem, and I'm going just to define a name property, which is string. Of course, there is nothing close to reality in this structure, but it just show you the way to structure your code. Execute operation, and that returns void. So that's it. If I go back, I have the subsystem now from the interface, and I'm going to export a class that is called, of course, game graphics subsystem, and that implements the subsystem. Oops, subsystem. Of course, it has a property called name, very original, and it has a constructor that will be receiving the property name. and this name equals n. Okay, and of course it will define the operation execute as we will be saying something to the console log, and we will be saying executing, I don't know, this name subsystem. Okay, so yeah, so we have that, and now we can copy this and we can create another subsystem. Let's say game network subsystem TS, and we just need to change a word. Yeah, okay. Game network subsystem. Yeah, right. And of course we can do the same for other subsystems. Let's say game logic subsystem TS, and we can do the same here. Logic. Okay. And finally for the game sound, sound subsystem. Okay, so we have that. Okay, now let's create the game world. So game world TS. So this guy will be exporting class called game world, and let's suppose we will be having, for example, a game map, and you will be having, for example, many other artifacts in the game world, like for example an array of enemies and an array of NPCs. If you followed my previous tutorial on the factory design pattern, so I've talked about that a bit. So you can have a container for that. And so, but we are going to make things simple. So we are just declaring the game map to be just a string. And let's say it will be having a specific game logic. Like for example, for a certain game, you would I don't know, you would load a 3D pathfinding logic. In another game, you would be loading a neural network. So it depends on your game, and this is just a property at this moment. Okay, and the constructor will be receiving those properties. So logic. Okay, so this game map equals map, and the we can say something like, for example, console log setting up game map, and you will say the name of the map that you are, I don't know, you are loading. For example, if you are developing a multiplayer game, and your players are connecting to the game, then they would see that the certain map is being set up. So okay, and of course this specific game logic equals logic. So I think that's it for game world. So what else did we do? This is subsystems. Yes, we have the 4 subsystems. We have the game world. Now we need to, yeah, the game itself. So the game ts, and this is going to import the subsystem interface. Yeah, and of course it's going to import the game world from game world export class game, and I'm going to make those variables private because usually in software engineering you don't want your data to be accessible to everyone. You need to confine the access to the data only through an interface. Luckily, TypeScript enables this way of structuring your data by using access modifiers like private, protected, and public. So the game world is private, and also subsystems list, which is an array of subsystems. Okay, so this is an array of subsystems. If you want to access anything, you will be iterating through that and you will be calling your various subsystems. This is one way of doing that. Also, we have the constructor, and the constructor will be receiving a game world parameter. And this game world equals game world. Oops. Okay, and this subsystems list equals an empty array for now. Now I'm going to implement the add subsystem method, because this method is very important to, you see, when I'm going to create every subsystem, I'm going to add it to the list. And this is the activity that the game builder is going to do. It's going to tell the game to create a subsystem, and it's going to store the subsystem inside a container. So add subsystem. Okay, and I'm going to execute the subsystem first, and after that I'm going to add it to the list. So push SS. Let me check the subsystem. Execute. Yeah, actually it's defined in every subclass. Yeah, it's defined here. Okay, so yeah, we have to set the game world, for example. Set game world, and that's in case, for example, I mean, when you initialize the game at the first run, you initialize the game world through the constructor. But when you are dealing with the game, when you finish your game, your instance, okay, you might want to set another game world and to continue playing, like loading another map. You finished one map and you want to load another map. So this method is for that purpose. So okay, and I'm going to say console log just for telling the user what's going on. Setting up game world, and I'm going to tell what game world is being set. Game world, tell the game map. Okay. So, and after that, I'm going to set the game world to this one. Okay, now I'm going to render the game, which is again just about telling the user what's happening. So console log rendering at, actually I'm going to define a time variable. So each time we are doing a render, we are saying the timestamp of that render. So time equals a new date object, and we are going to local time stream. Okay, so the user will always know if in case something happened, for example, a frame was corrupted or there was a bug or an error. So usually if you are programming something and you expect errors, and you should expect errors, then it's better to know when exactly that happened. Of course, when you are debugging your application, you can see the call stack, and you can trace which function caused the error. But sometimes you also want to define some timestamps. So render, we have render. Now let's define update, and update is actually the same, only I'm changing updating. Okay, so I guess this is it for the game, and maybe now we need to come back to the game builder, I guess. So build game, before build game, we can define a constructor if you need to set something for your design, for your builder, but in our case there is nothing to set up here. So we are going to define private methods. If you see the diagram, the client, which is the director, will only call the game builder and the build game method from that builder. The director doesn't know or doesn't care about initializing the graphics subsystem or building a network subsystem or building the game world, etc., etc. These are the responsibility of the game builder itself. Hence, these methods are being private. The only interface that is exposed to the outside world is build game method. So in this case, we are going to say private init graphics subsystem, and this guy is going to return a game graphics subsystem, and of course I'm going to return new game. I'm going to return a new instance of game graphics subsystem, and I'm going to say, let's say GPU init. Okay. Other than that, I'm going to do the same for, you know, the other subsystems, like build network stack or build network subsystem, and it's going to return a network subsystem and of course here too. TCP IP stack initializing. Of course it should be grammatically correct as well. Okay, so yeah, build network subsystem network, yeah, that's okay. So let's do this for the rest of the interfaces. So in this case we have build game world, and the build game world will return a game world, and it's going to have two parameters: the game map, of course, which is of course a type string, and specific logic module, which is of type string as well, and it will return a game world instance. Yeah, let's just transfer those parameters and see. Okay, what else? Let's see. So we have now the sound subsystem and the logic subsystem. So I'm going to say build game logic, and I'm going to return the logic subsystem, and I'm going to say neural networks module. Okay, or actually I'm going to just to say logic model. Okay, what else? Oops. And the sound. Okay. Init sound subsystem, and it's going to be returning sound subsystem, and oops, okay, so let's say something different a bit. Initializing SEO audio subsystem, for example. Okay, so so now we have created methods to deal with different subsystems, which are the steps of the pipeline of the design pattern. And now I'm going to actually call these. So constant game world equals this, and we are going to build, and let's call the map whatever, steps to heaven, for example. I don't know if any game has a map that's called something like that. And I don't know, neural network module or logic. Okay, and in that case I'm going to pass that game world into the game constructor. And after that, const, let's say graphics subsystem equals this, and we call the method that is responsible for that. And after that, we add that subsystem. So graphics subsystem, we add that graphics subsystem to the container of all subsystems. And of course, I'm going to copy the rest because I don't want to type a lot. So we create the network subsystem, we call the build network subsystem, we add the subsystem to the container that in the game. And after that, we say, for example, that we want to create the game logic, and I'm just calling the method because it returns the build game logic. It returns an instance of the game logic subsystems, and I'm adding that directly to the container. And the same I can do with, let's say, so game add subsystem, and here I'm going to call the sound subsystem, for example, like this. Okay. And after that, I return the instance that I have created. So now I have the game instance. I think we are done. Unless I have forgotten something, but we can try. So let's say we want to run this, Dino run allow read main ts. So let's hope for the best. Yeah, it's working. Yeah, so you can see first we are initializing the GPU, then we are initializing the stack, then we are initializing the game logic and the sound subsystem, and we are creating the game world, setting up the game map, for example, steps to heaven. And after that, we are executing the rendering and updating, and with each step we are writing the timestamp for that. So as you can see, this is, I'm going to stop this. So as you can see, whenever you see a complex object, it's sufficient to remember that you need a builder, and that builder is actually a pipeline. Let me go out. And that builder is a pipeline actually, and that you need a director to tell the builder what to do, which phase to execute. And actually the director actually doesn't influence the steps themselves. It just tells the builder to create a game, for example. Okay, and the builder takes care of the steps themselves, and that's it. So you don't create a game instance, you don't create an instance of that complex class yourself. You tell the builder to do that, and that's it. So I hope you have enjoyed this tutorial. I hope you have learned something useful from that. In case you have any questions, please leave them below, and I'll try to answer them as quickly as possible. Other than that, please like and subscribe. If you have any comments and suggestions, please leave them else below. If you didn't like the video, please tell me why, so I can try to improve my content creation in the future. Other than that, I wish you all the best and see you in the next time.